Welcome. This is a short video just about my cool little box here, the Miniboss controller. It's just a simple digital controller designed for fairly low amp kilns. So, quick disclaimer: I'm just a guy on the internet. If you're not capable of working with voltages that could kill you and temperatures that could burn your house down, then get supervision from somebody who is qualified before you go messing with any of this stuff, and certainly before you go applying power to any kind of system like this. All that fun stuff said, it's a fairly simple little device here, and it's made up of parts you can easily get, and everything is basically being used exactly for what it's designed for, with the possible exception of the box and maybe the extension cord. So here's what we got here, just some simple features. This is a simple PID control unit, and I'll talk a little bit about what that means later in the video, but basically it controls the temperature of a kiln by turning that kiln on and off. That's all it does, on and off. It doesn't apply more or less power, and that's pretty much how adult digital controllers work here. Now, in this case, we've also got over here a little foot pedal. This is because this is for a very small little kiln, and we're going to be working with it in close proximity to metal tools, potentially, and stuff like that. So, if you need to fish out a little piece of glass from a kiln with metal coils in it, it's a good idea to be able to shut everything down quickly and easily. So this will be altered so that it fits between the kiln and the control box here. But that aside, this basically goes out to the kiln. This comes in from the wall, on, off. This tells you when the elements are being turned on and off. This little receptacle over here is where the thermocouple goes. That's wired into this. I'm going to talk a little bit about some of the tools and the little parts, and there's a complete parts list on a website which is fiammaglass.com, and I'll put up a link for all that. They're just little Amazon links. You can get the parts wherever you want, of course, but if you do it through the links on the website there, I get a tiny little bit of kickback from Amazon, which maybe someday in a few years will pay off part of this video camera or something, I don't know. So, take a look, and through the magic of video editing, I'm going to go and have a look at all the little bits and pieces that make this up, and then I'm going to take it apart put it together and then take it apart and show you how everything is all connected. I'll be adding a nice little wiring diagram in there too. This is a very basic video. It's not intended to be a full tutorial on how to do every little step, although you can ask me questions where I post this, and I'll try to answer as I can, and hopefully I'll get a little time to reshoot some of this stuff a little better and maybe add some more detail on some of the parts and processes if people are interested. So there you go, and thanks for looking. Alright, so getting ready to do the build. Got some parts in the mail and some tools, and just wanted to talk about them real quick before we get started. First, some motivation to finish the job soon. And this is a multimeter. Should be familiar with this if you're gonna play around with electronics. This is a good one, and easy to use. There's lots of great videos. I'll put some links on there. Basic electronic stuff can be dangerous, so even using some of these tools improperly can be dangerous. This is one of them, so definitely take your time, figure out what you're doing before you get in too deep, and make sure you have help if you're new to all this with someone who is experienced. Next to that, I got a little laser infrared thermometer. It's like 20 bucks. It's great for checking stuff. I figured it would be terrible. It actually seems to be fairly accurate. It's good up to like 1300 something degrees, so for our purposes it's perfect. Some basic tools, some wire strippers, some wire clippers, what have you. I've got a really neat little crimp here for different plugs and stuff like that, which I'll talk about more in a minute. Some hookup wire, basic stuff, lots of pretty colors. Now this is the controller that I'm going to be using for this. It's a really inexpensive set point controller which is good if you're doing this as a parts oven. If you're doing it as an annealer, if you're actually going to cook stuff in it, then you're probably going to want to ramp soak a controller, which there's also going to be links for that available, and there are good ones out there, and I'll talk more about that in a different video. For our purposes, this is a parts oven, so I'm not planning on doing long cycles on it, so a set point controller is just fine. Things like 20-25 bucks, super cheap. But if you get it as a package deal, it's also pretty cheap to get the parts. It will come with often a relay. This is a solid state relay, a little heat sink, and a thermocouple. I have these, I got them anyway, because they're cheap and I use them mostly for other stuff. The heatsink, this is really designed for using inside of a case. It's not great for outside of a case. I actually use it externally in some other projects and it works okay. But the heatsink I got for this project is definitely better. The relay is cheap. You get what you pay for, but you know, I've used a lot of them and they seem to work pretty good. If you want to do this on cheap, it's not a bad way to go. I ended up getting another one for this project because I wanted to upgrade a little bit, but they're both fine. The thermocouple that comes with these almost always has a little button end instead of a probe, so it's not so useful for the project, but it is good to 800C, which is like 1400 something Fahrenheit, so useful potentially. I keep them and use them as extensions. With thermocouple, you can't extend them with regular wire. You need thermocouple wire. So an extra one becomes fodder for extensions generally later on, or internal extensions if I need to, and so on. So good to have around. I actually ordered another one, which I can't find right now, but it'll turn up, that has a nice little 50mm probe, and that's what we'll be using in this project. Over here is a drill. Yes, you need a drill. Drills are good. Now this is a oscillating saw. It's really sweet for cutting up project boxes. You can just use a cheap old hot knife or X-Acto or any number of other things. There's lots of great ways to cut up project boxes, but if you got the scratch, man, are they sweet. They make it like just so much easier. And an extension cord, which is going to hack to bits. You can always get one of these little plugs and make your own cords, but extension cords are so cheap, it sometimes just makes sense to hack them up. That's 16 gauge. This is a 12 amp max system we're building here, really closer to 10, and so 16 gauge is adequate. Any more and you'd probably want a little beefier cable. Now here's where some of the fun stuff is, some of the little bits and pieces. I like these little DIN rail terminal blocks to clean things up. You can see they come with jumpers, and this is going to make our wiring a little neater, though it is totally unnecessary. It's nice. We got a nice little switch rated up to 20 amps, so we'll need that. Some thermal grease, and this is going to be used on this heatsink. Now this is a much better heatsink for what we're doing. It's a real external heatsink, and it's much more effective the way it works, and should look real nice on the top there. The relay itself, which is over there down in the bottom right, will fit on the front of that and penetrate the side of the box. And I'll check that out soon. Now here's some fancy little plugs. I use them all the time. I like crimping stuff. It's fast. It gives you the ability to pop things in and out. Also totally optional. There are other ways you can go about it without it. But included in the links, one of these. It costs like 20 bucks and it crimps like every kind of plug known to man, and it just makes everything easy, and it prevents a lot of soldering you might have to do as well. Next to that, we got a step bit. They're pricey, but for drilling holes in project boxes, they are hard to beat. And next to that, a big flashy light, because you know, we want to know when things are turning on and off. And here's the relay. This is a very slightly more expensive one from Auber. I like it because I can actually call a real person and talk to them if something goes wrong. So far I've had pretty good luck with them. They're a little bit more expensive than the Inkbird version over there, but so far so good anyway. This is a special thermocouple plug and receptacle, also from Auber. Few bucks, and it makes it so you can take things apart, makes everything more portable. You can't use normal plugs with thermocouples, just like you can't use normal wire. It has to be a special kind or it messes with the readings. This is that. And that's pretty much it. Thanks. I'll get back to you in a little bit with the layout, and we'll start construction. Alright, so here is the box with all its cuts. This is the front. That's going to have the controller. That's going to have the big flashy light. That's going to have the switch, the on-off switch. This is the power in on the right side if you're facing away. On the left side, you got the power out. That's going to be where the Molex plug ends up with a little pigtail. And this is for the receptacle for the thermocouple. Up here you have the space where the relay will poke through the side of the case into the interior, and the holes that'll hold the heatsink in place up there. For some people, hacking this apart is going to be the hardest part. Just be patient and do the best to make sure your stuff fits kind of snug. It's better if the holes are just slightly ragged and it fits in there snug, or if you're a perfectionist about it and you ream them out too much and they're wiggling all over the place, that's more of a problem. You can fill the gap with a little JB weld or something like that, but you want to avoid that problem if you can. So there we go. Now I'm going to put it all together and make sure everything fits like it should, and I'll come right back. Alright, here we are with everything wired together. A couple things I forgot to mention in the last section on bits and pieces. The glands here, these little strain relief guys, these are the waterproof kind, which you don't particularly need, although it's not, doesn't hurt. The reason I use them mostly is because they work by squeezing a rubber gasket down around the cable, which makes them pretty flexible for a lot of different uses. Plus they come in the nice little variety packs, which is on the website there. So they're great. This is a fairly thick project box. To make them work, you need to remove the little rubber washer that's in there. So it isn't truly waterproof. You probably don't want to put it out in the rain, but I'm not sure why you'd want to anyway. So they're great, they're cheap, whatever. You could use an alternative strain relief if you like. And then the project box itself, which isn't actually a project box. What it is a wall mount junction box. It is also water or weatherproof with a little rubber gasket and so on. Primarily I grabbed this, I used this one because it's dirt cheap, and it's available in like every hardware store ever. Almost any project box will work, but these are nice. They're thick, so they're a little bit of work to get through, but it's worth it in, my opinion, if you're only making a couple anyway. I'm going to talk a little bit about all the wiring here. You'll have seen a wiring diagram, and I'll include a link to it as well. Notice, of course, everything is left long enough so that I can open things up nice and easy. You've got your power coming in on this side, hot, common, and ground, and they all feed into the little jumper terminal block here. You can see there is three things going on. So you've got the hot coming in here, and it splits off using this jumper to a couple different places. The common over here jumpered together also, and then the ground in the middle, which is just running straight through, and it actually goes directly onto the kiln load, as it were. And from there, we've got all the other goodies coming out of the power. So our hot line goes straight over to the switching side of the relay. That is the part that gets turned on and off. So it's an interrupt right there. This is a 120 volt system. If you were to take apart a field kit from another manufacturer, an AIM1 or whatever, you would see it wired up a little bit differently for two poles. This will only work on 120 volt, whereas those you could switch back and forth fairly easily, which is why it's just a standard in the industry for the most part to do them wired for 220, because it's easy to adapt to 120 or 240 for 120. So anyway, that goes there. You also see this one coming off to power the PID unit. Typically these guys it doesn't matter which pole is which as far as the power in there. The red and yellow here are that. So you can see you've got the red coming in and the yellow going out to common. Wouldn't matter if you mix them up. And the blue and green here are the control power. So these are what the relay uses to power the relay on or off. So a little 12 volt current when the PID says so, will flow through there, and it will cause the switch side of the relay to close that circuit, and it will power your element. And you can see from there the hotline goes on to load right there, and the white comes back over to here. Of course, coming in, I didn't mention you've got a simple switch here. This is just a simple 2-pole on-off switch, and it interrupts before it makes its way there. You also see that I've got this 120 volt little LED wiring directly off of the relay and then back to common, because I want it to light up every time that this switching side of the relay is connected. And of course over here you've got the thermocouple. It goes back to the little thermocouple receptacle here. It is also thermocouple wire. It can't just be plain wire. It has to be thermocouple wire. So this was cannibalized from the little cheapo one that came with the controller, and it just feeds the receptacle, and then I can have the other side plugged to my thermocouple. And that should pretty much cover it. As I said before, if you want to do this a little cheaper, you could use wire nuts instead of the fancy little DIN rail here, but it's nice and it looks pretty. You can see here the relay. This is the heat sink for the relay. The solid state relay here is got full contact with the whole back, and it really does a great job of diffusing the heat. And that's pretty much it. Over here you can see I've used a Molex connector rather than just a plain old 3-prong or something like that. The reason for that is because I want to make it so that the kiln end of things, which doesn't necessarily have its own switch, doesn't just get plugged directly in the wall and just melt down. So I use a more unusual plug there. It works for lower amps. For a higher amp system, you need to substitute something else, or maybe just use a plain old 3-prong or something like that, and make sure your kiln has its own power switch. So hope that helps, and if we have any other questions, I'll do my best to answer them, and thanks a lot for watching.